Have you ever wondered how a platform like Shopify manages to power millions of online stores, all at the same time? Especially during something insane like a Black Friday sale? Well, it's a huge engineering puzzle. Today, we're going to pull back the curtain and actually design a system on that scale, right from the ground up.
So here's our game plan. First, we'll get a handle on the problem itself. What exactly are we building? Then, we'll hit our first big fork in the road, the architecture. After that, we'll dive into the core services and the data backbone that ties it all together. And finally, we'll put our design through the ultimate stress test, a flash sale, and talk about the tough, real-world trade-offs that engineers have to make every single day.
All right, before we even think about writing code or picking a database, we've got to start with the most important question of all. What problem are we actually trying to solve here?
This right here is the central question. This is our North Star. Every single decision we make, from the servers we choose to how we structure our data, has to answer back to this.
When you really boil it all down, we're tackling 3 monster challenges. First up is multi-tenancy. Making sure thousands of totally unique stores can live together on our shared hardware without tripping over each other. Think of it like a giant apartment building. You definitely don't want your neighbor's burst pipe to flood your apartment. Second, there's just the sheer scale of it all, handling that unpredictable wave of traffic. And third, reliability. Because for any business owner, every single second of downtime means lost money, plain and simple.
So, those challenges, they translate directly into our technical promises, the things the system just has to do. It's got to be scalable so a traffic spike doesn't crash everything. It needs to be super performant because slow loading pages kill sales. It has to be highly available. We're talking 24/7 uptime. And it needs to be fault tolerant, so if one little piece breaks, the whole ship doesn't sink.
Okay, so we've got our goals. Now we're at our first major crossroads. How do we structure this whole thing? This is the classic, age-old debate, monolith versus microservices. A monolith is kind of like one giant all-in-one skyscraper. Everything's connected, which makes it simple to build it first. The problem? A fire in the kitchen can bring the whole building down. And if the lobby gets too crowded, you have to reinforce the entire structure. Microservices, on the other hand, are more like a campus of smaller, specialized buildings. A problem in the library doesn't shut down the science lab. If the lecture hall gets super busy, you just expand that one building. It's more flexible.
Now, this diagram might look a little bit like a subway map, but it's pretty much the standard way modern big apps are built. Let's just follow a single request. It comes in, hits a load balancer so no single server gets overloaded, and then goes to an API gateway. Think of that as the main receptionist. It knows exactly which microservice to send the request to, whether it's for orders, inventory, or something else. And you see how each service has its own database? That separation is the absolute key to scaling independently.
But here's the plot twist. You'd think a massive site like Stack Overflow would be all microservices, right? Nope. It's a powerhouse of a monolith. And this is such a great reminder that there's no single correct answer. For them, the simplicity of having one codebase must have been a better trade-off than the complexity of managing dozens of different services. It's always about picking the right tool for the job.
Okay, so for our design, let's go down that microservices path. It just makes more sense for a platform with this much variety. So the next question is, what are the essential building blocks we're going to need?
So, if we break it down, we get these specialized units. The product service is the librarian. It manages the entire product catalog. The inventory service is the bouncer. It knows exactly how many items are left in stock. The order service is the conductor, orchestrating the whole show from checkout to shipping. The payment service, well, that securely handles the money. And then you have the search service, which helps customers find what they're looking for instantly.
Okay, we have our services, but where do they keep all their information? That brings us to the data backbone. And let me tell you, getting this right is absolutely critical. Data is the lifeblood of this whole thing.
And that brings us to this key concept, multi-tenancy. This is really the secret sauce that lets one big platform serve millions of totally separate merchants. The real magic is in the isolation, making sure that one store's data is completely invisible and walled off from every other store.
So how do you actually pull off that isolation? Well, you've got 2 main approaches. On the left is the shared model. It's efficient, it's lower cost, it's like that big apartment building we talked about. But you have to worry about noisy neighbors. On the right, you have the isolated model. This is like giving every single merchant their own private house. You get perfect data isolation, but as you can imagine, it's way more expensive and complicated to manage. Now think about how people actually shop online. You might browse dozens, maybe hundreds of products.
That's a lot of reading data for every single one you actually buy, which is a write operation. So we can optimize for that. All the writes, like placing an order, go to a single primary database. That primary then immediately copies the new data over to a bunch of replica databases. All the browsing traffic? That goes to the replicas. It spreads the load beautifully and keeps the site feeling snappy.
But what happens when you have so many people buying stuff at once that even your primary database can't keep up with the writes? That's when you bring in sharding. All this means is we split the data horizontally. It's like instead of one gigantic phone book for the entire country, you have separate books for each state. For us, we'd use something like the store ID to decide which database shard a particular store's data gets to live on.
All right, we've got all our pieces. Now it's time to put it all to the test with the ultimate challenge for any e-commerce platform, a massive, sudden, system-crushing flash sale.
This diagram is great because it shows the typical journey of a growing website. Look at the top left. Everybody starts there. One server trying to do everything. That doesn't last long. The first step is to split your app and your database. Then, as more people show up, you add a load balancer out front and you just start cloning your app servers to handle all the requests.
Now we're getting into the really heavy traffic. This is where we bring in the big guns we just talked about. We add read replicas to handle all the browsing, and then we shard our database to handle all the writes. And the final stage of that evolution, it's breaking that one big application into all those independent microservices we planned out earlier.
And hey, don't just take my word for it. This is literally from Shopify's own engineering block, their playbook for building resilient systems. They've thought about this stuff deeply. This is how you prepare for the storm before it hits.
The main takeaway here is that you have to design for failure, not just hope for success. You use load testing to find the breaking points before your customers do. Circuit breakers are like the fuses in your house. They stop one failing service from taking everything else down with it. And they use something called idempotency keys, which is just a fancy way of making sure that if a customer's internet glitches and they accidentally click buy twice, they only get charged once. It's a critical safety net.
So we've designed a pretty powerful system. But building things in the real world is never about finding a perfect solution. It's always about making smart, informed compromises.
And these are the kinds of choices that keep architects up at night. For instance, consistency versus availability. If there's a problem, do you show inventory data that might be a few seconds out of date? Or do you just show an error page? Tough call. Or what about build versus buy? Do you spend the time and money to build your own search engine, or do you just pay for a specialized service? There's no right answer. Only the right answer for your specific situation.
So, to wrap this all up, I'll leave you with this question to chew on. This gets right to the heart of what makes building a multi-tenant platform so difficult. It's not just about data isolation, it's about performance isolation, preventing those noisy neighbors. Figuring this out, well, that's what separates a good design from a truly great one.